Hello friends, I welcome you on BYJU'S Exam Prep, India's most comprehensive preparation platform for all the engineers. All the candidates who are joining me live, just quickly confirm your presence in the comment section and tell me whether my audio, visual quality, everything is okay so that we can proceed with the session. Friends, today's session is going to be a conclusion to a series of sessions we were having for your subject power system as far as GATE 2023 is concerned. We have discussed some of the important chapters, important concepts for your examination, that is GATE 2023. We talked about the basics of transmission line, we talked about the compensation, we talked about stability, and we talked about the fault analysis. In this session today we are going to have a Mentimeter session. Let us first understand what is this Mentimeter session. This is going to be a quiz for approximately 10 questions I am going to present. Now the purpose of this session is to give you some idea about your accuracy and speed both at the same time. All the participants are supposed to log into the menti.com. You have to go to some other particular whether you have the laptop or the mobile, you have to go to the website menti.com, menti.com, and he will be asking you a code to join this particular quiz. I will be telling you the code also. The code is 96742840. It's 96742840. So all the candidates who are joining me live, just quickly go to the menti.com, use this code and join this quiz so that we can quickly start. Yes, everybody who is joining me live, just quickly confirm, are you able to follow this or not? The moment you are going to join this, I will be getting the notification here. Yes, Prince, are you able to join? Just now I have given you the code. I am just putting it again. It is 96742840. If you are not getting it, I am repeating it. Go to the menti.com. If you want to attend the live quiz, go to the menti.com, menti.com. He will be asking you a code. That code is 96742840. So are you able to join? Everybody just tell me in the comment section. One candidate has joined, two candidates. So everybody, can you just please share it with your friends and colleagues so that more and more people are going to be joining us? Yes, everyone. Just join it fast so that we can start. So I hope people are going to join in between the session. And let us start. So all the candidates who are joining live, once again I am repeating, go to menti.com, use the code 96742840 on some other device to join this test. You must have a pen and notebook because some questions are going to be conceptual and some questions are going to be having little analysis also. Is it clear? Are you able to follow? At least tell me yes or no in the comment section. Still only two candidates. Just quickly fast join the session, then only you will understand that how speed and accuracy both are required to crack a competitive examination like GATE. Is it clear, everybody? So I hope you are going to join soon. So let us start with the session. I already have some candidates. See the first question in front of you. The first question talks about the real and reactive power drawn by the motor, and the rating of the motor is given as 15 horsepower, 440 volts, and it is a three-phase motor and it is operating at full load 85% of the efficiency and 0.9 power factor lagging. He is asking you to find the real and reactive power. Everybody, don't answer in the comment section. Just join the menti.com, use the code 96742840, and within the time limit, 15 seconds are remaining, you will get some idea about how speed and accuracy are going to be two important factors for success in any examination, and then you can improve upon that. So not a single candidate has given the correct answer. The correct answer is 13,169 watts is the real power and 6365 is the reactive power. Now let us try to understand how you have to approach this particular problem. He is giving you the rating of the motor in horsepower. Whenever the rating of the motor is given in horsepower, it means he is giving you the output power, because the output of the motor is mechanical. Motor has input electrical power, output is mechanical power. So if he is giving you the horsepower as the rating of the machine, you please understand he is talking about the mechanical output. Output he has given. He is asking you the power taken by the motor. It means what you want? Input power. First you talk about the real power, and from the power factor relation you can find the reactive power also. 15 horsepower multiplied by 746, because 1 horsepower is equivalent to 746 watts. So you will be getting total electrical equivalent power output for the motor. Use the efficiency relation. Efficiency is also given, 85% efficiency. What is efficiency? P output upon P input. P output you know, efficiency you know, 85%, you can find the P input. It means real power taken by the motor you can directly solve now. He is also giving you the power factor. If you know the power factor, you know the power factor angle. Yes or no? And you know the relation from the power triangle P, Q, and the resultant is the complex power. And that angle between the apparent power and the real power is the power factor angle. From here you can find the power factor angle, cos inverse 0.9. And now you can establish the relation reactive power is equal to real power multiplied by tan phi. In the power triangle, you can simply apply the tan phi and you will get the relation between P and Q, real and reactive power. So you have already calculated real power, you can easily calculate the reactive power. Everybody just tell me in the comment section, are you able to follow this? I will request you, all the candidates, please do not forget to join the menti.com if you want to experience the real importance of speed and accuracy in the examination like situation. So let us go to the next question. Let us go to the next question. But no candidate has given the right answer. Only one candidate has given the answer. It's okay, Prince. Keep on trying. See the next question. See the next question. Very easy question. I think this question a lot of you can solve. It is a very basic question related to per unit. He is giving you the base current and the base voltage, and he is asking you the base impedance. Directly divide the base voltage by the base current and you can get it. I think this is going to be just an oral question. No need to do anything. Directly you can answer it. This is why I have just given you 10 seconds. So only one candidate was able to give the right answer. Let us see the leaderboard. I think this time Prince has given the correct answer. No, Prince, again you are wrong. Why? So Anila has got the correct answer. See, this is not just about doing the question. It's about doing the question in the shortest time. That will give you an idea about your speed in the examination. This was a direct question. I hope everybody can do it. So let us proceed to the next question. Yes. See the third question. Third question. A very interesting, very simple, but yet very confusing question. For a fixed value of complex power in a transmission line having a sending end voltage V, the real power loss will be proportional to. It was a very easy question, so I have just given you 30 seconds to answer this. Anybody who still wants to join this quiz, you can join it. You have to go to the menti.com, menti.com, and you have to use the Menti code as 96742840. Already I have mentioned the Menti code in the comment section. If you want, you can join. So the correct answer is 1 upon V square, and only one candidate was able to give the correct answer. Let us see the leaderboard. Let us see who has given the correct answer. So Nitin has given the correct answer, and now Nitin is at the first place. So if you give the answer fast, you will get more points, so you can get to the top position. No quiz, no other quiz is going to give you the idea about your speed and accuracy together. This is only Menti Quizzes having this property. Okay, let us go to the next one. See the next question. Yes, everybody. In the previous question, you are just supposed to relate the sending end voltage with the complex power and keep the complex power as constant, and you will get the relation. Now, very direct theoretical question, but a little tricky one. Let us see whether you are able to solve it or not. He is saying, which of the following length of the transmission line is suited for the representation in equivalent pi model? So some candidates, they get confused whether it is medium transmission line or long transmission line. So you must be aware that it is equivalent pi model, equivalent pi or equivalent T model. They are related to the long transmission line. And you know, in general, the criteria for length for the long transmission line is length more than 160 kilometers. So out of the given options, if you say 50 kilometer, no, 150 kilometer, no, 250 kilometer, yes. So 250 kilometers is going to be the correct answer. Let us see the leaderboard and what is the current rating of the students. So I think this time Prince has given the answer very fast, Prince and Nitin. So now Prince has got the second position, but Nitin is still at the first place. And one more candidate has joined the Menti, that is Bran the Broken. Very interesting name. So I hope you understand this was a direct question. Let us go to the next question. See the next question. Be attentive, be alert, as if you are sitting in the real examination, and try to give the correct answer on your screen. The surge impedance of a three-phase 400 kilovolts transmission line is 400 ohms. The surge impedance loading of the line is. I have just given you 30 seconds because this is one of the most classical question for the transient analysis of the transmission line. And you know that surge impedance loading is nothing but the rated V rated is square upon the surge impedance. Both the voltage and the surge impedance is given. Directly you can find it. So two candidates have given the correct answer. One has given the wrong answer. Let us see what is the status at the leaderboard. Who has given the answer correctly? So there is a fight between Nitin and Prince. And Prince has given the correct answer fast. Now the fight is very close. Nitin at the first place, Prince at the second place, and then we have Mr. Anila and Bran the Broken. Bran the Broken, be active in attempting the questions. Okay. Now in this question, let me tell you what you were supposed to do is, just give me a moment. Yes, you have to simply apply the formula V square upon ZC. But please understand, I want to give you some idea about the surge impedance loading. Lot of people, they are confused. What is surge impedance loading? So I will give you a just one statement definition of surge impedance loading. Surge impedance loading is nothing but the ideal loading condition of the line. If you give a loading which is equivalent to the surge impedance loading, then there the transmission line is not going to behave as a source or the sink of reactive power. It means the transmission line is neither supplying the reactive power nor it is absorbing the reactive power from the external source. It means whatever is the requirement, reactive power requirement of the transmission line, that it is fulfilling on its own. I hope you are getting this. And there are a lot more characteristics of surge impedance loading. The magnitude of the voltage is same everywhere on the line. The magnitude of the current is same everywhere on the line. The power angle between the sending end voltage del is equal to beta L, and the phase angle between the voltage and the current is 0 all across the line. All across the line. Is it clear, everybody? You can say voltage and current, they are in phase at each point on the line. So all these conditions tell you that this is the ideal loading condition of the line. But we generally talk about the economic loading of the line because we have to run our system economically. So generally what happens, the loading is more than the surge impedance loading condition. So whenever loading is more than surge impedance loading, what is happening? Your line is having a requirement for the lagging reactive power. Is it clear, everybody? Yes, Tarun. So let us proceed to the next question. Enough information about the surge impedance loading. The rest you can read from your notes or you can attend this session. Let us see the next question. Okay, I think I have missed that question. Just please wait. Yes. Now, let's start with the next question. The candidates who are attempting the quiz, they must be enjoying it. Now, this is again a very interesting question related to the reactive power absorbed by the shunt reactor based on your reactive power compensation. You have to relate the reactive power absorbed by the reactor in terms of the voltage and the frequency. You know how to relate it. And he is saying the voltage and the frequency changes are mentioned. Voltage has become 98% of the rated voltage and frequency has become 96% of the rated frequency. And you have to give what is the reactive power absorbed by the reactor in case of the changed voltage and frequency case. Yes or no? I think you can do this question. 5 seconds remaining. Let us see who has given the correct answer. Nobody is able to give the correct answer. My God. I don't know why. So the ratings are at the same place. Now please try to understand in this question what you have to do. Please remember, whenever an element is connected in series, how you are going to write the power with respect to the current. So you are writing current is square multiplied by the element resistance or the reactance, whatever you want, whether you want the real power or reactive power. If the element is connected in shunt, then what is the formula you are using? Voltage is square divided by the resistance or reactance of that element. You are talking about the reactive power. Yes or no? So you are going to write the reactive power as 3 times V phase square upon XL. XL is what? The reactance of the shunt reactor. Now you know that voltage is per phase voltage. We have multiplied by 3 so that you get the 3 phase power absorbed. But the denominator x you can write as omega into L. What is omega? Omega is 2 pi f. Now 2 pi, they are constant. L is also constant, is not going to change. So what is changing? Frequency. So V square upon F is going to be the relation for the reactive power absorbed by the shunt reactor. So you have to find what is the changed value of the reactive power absorbed. Is it clear, everybody? So let us see the next question. Let us see the next question. If you are getting a good question, don't worry. Don't be in a hurry. Try to solve it correctly. Because this is just for your practice. Even if you are not getting marks, you're not getting a score here, no problem. But in the real examination, it will help you to score well and increase your speed. Again, this question is talking about the surge impedance loading, but here some series capacitive compensation is also given. Again, this is one of the classical question we discussed in some of the previous class also. Just try to do it. Yes. First thing you have to understand that how you are relating the surge impedance loading with the surge impedance, because what the series capacitive compensation is going to do, the series capacitive compensation is going to compensate some of the line reactance, series line reactance. How much? He is saying 30%. So what is the remaining one? The remaining one is 70%. So in the second case, you have to choose the line reactance not as X or L, but as 0.7x. That is the only thing you have to do, and relate the surge impedance loading for the two cases. Again, not a single candidate was able to give the right answer. Please follow the method I have given you. Okay. Still, if you face problem in any of the question, you can take the screenshot. Do join my personal Telegram channel on BYJU'S Exam Prep, that is Electrical by Ashutosh Saxena. Post that question and I will try to help you as much as possible. See the next question. Now this is just a formula based question. So this question I think everybody must be doing. He is giving you two conditions. One condition when compensation is there, when shunt capacitor is there, when shunt capacitor goes out of the service. When shunt capacitor goes out of the surface, that is the case without compensation. So that gives you phi1 in terms of your formula. Reactive power supplied by the shunt capacitor is equal to P load, that is the real power of the load, in bracket tan phi1 minus tan phi2, where phi1 and phi2 are the power factor angle for the case without shunt capacitor and with shunt capacitor. In this formula, you just need to put the values. You will get the power factor of the load when the capacitor goes out of the service. This question you must be doing. If you are not doing this question, it means you have to be very serious about your preparation. Still no candidate is able to give the correct answer. No need to see the leaderboard. Let us go to the next question. See the question on your screen. Yes, everyone. Now this is a good question. This question is from the dynamic compensation, synchronous phase modifier. Because the synchronous motor you are using here is not on no load. It is having some real load connected to its shaft. That is why it is saying a 120 kilowatt synchronous motor is connected. So overall power factor becomes unity. I will tell you what is the meaning of this statement after the timing, but you try to solve it. Okay, just give your attempt. That is important. It gives a brain exercise. And brain exercise is very important. Whenever you see a question, do not run after the solution. Try to do some exercise in your brain, because that will help you a lot in the examination. Examination, you get 100 questions, 60 questions, or whatever questions without any hint or solution. And this is the reason most of the people, they are saying, sir, we are reading a lot, we are doing a lot of efforts, but still we are not able to get success in the examination. Why? Because you are reading a lot, but you are not giving a proper training to your brain. That is very, very important. If I go to the gym for the first time and somebody gives me 50 kilogram of dumbbell, what I will do? Yes. But if I am going to the gym first time, I am taking 5 kilogram dumbbell, slowly I am increasing the weight. Then one day, maybe if I am regular, disciplined, and I am doing the practice, I can take 50 kilogram of dumbbell. The same thing applies to your brain also. In the examination, you are putting 50 kilogram of weight on your head, but you are not training your brain even for 5 kg of the weight. So never run after the solution. Is it clear? So only one candidate can give the right answer. What is this? This was other question, na? Just give me a moment. Yes. This was the question we were discussing, na? So we have already discussed this question. Yes. Let us see who has given the correct answer. Oh, now there is a fight. I hope. Okay, very close. So Prince, you started as the first candidate, but anyhow, you managed well. Okay, so keep up the good work going. And definitely other candidates also, Anila and Nitin. Nitin, congratulations, because you are at the topmost position. But other candidates also, do not forget to keep on trying and making your efforts. That is very, very important. So see the last question for today's quiz, question number 10. Are you finding the question interesting? Tell me in the comment section. A very direct question. Synchronous motor takes leading current when it is. I will tell you a shortcut how to deal with this type of questions. It looks like very simple, but most of the time people give the wrong answer even in the real examination. Just given you 30 seconds, because if you know the trick, you know it. If you don't know it, you don't know it. Yes, 2 candidates have given the correct answer. Let us see the leaderboard. I think there is going to be a close fight between Prince and Nitin again. Oh, so close. That's great. So finally, congratulations, Nitin. You are at the top position, and other candidates, lot of wishes for you also, because if you keep up the good work going, definitely you will reach to your destination. But one thing for this question I want to tell you, how to remember whether it is a synchronous generator or it is a synchronous motor, and how to get to know at different operating conditions whether it is overexcited, underexcited, normal or level excited, what is going to be the operating power factor. I am giving you a very easy trick to answer that. First thing you remember, whether it is generator or motor, overexcited condition means the machine is going to supply lagging reactive power. That's it. Whether it is generator or motor, the machine is going to supply the lagging reactive power. When I say the machine is going to supply lagging reactive power, it means it is absorbing the leading reactive power in the overexcited condition. Something for your notebook. Under excited condition, whether it is generator or motor, we say the machine is going to absorb the lagging reactive power, whether it is a generator or motor. Under excited condition, if the machine is absorbing the lagging reactive power, the same thing you can say in other words as the machine is supplying the leading reactive power. In the normal or level excited condition, the machine, whether it is generator or motor, it is neither acting as a source or the sink of reactive power. So no need to talk about the normal or level excited condition. Now suppose you are talking about the motor. In the motor overexcited condition, what is happening? It is acting as a source of lagging reactive power. It means it is absorbing leading reactive power. Now what is the basic nature of motor? The basic nature of synchronous motor is to act as a load, to absorb power. What type of power it is absorbing? It is absorbing leading reactive power. So what is the operating power factor? Leading power factor. The question was asking, are you getting that? It's okay, Nitin. Better luck next time. No problem with that. So friends, thank you so much for joining me live in the discussion. I hope you enjoyed this Menti session. So friends, if you find this quiz suitable for your preparation, and if you want more such videos, do not forget to subscribe to BYJU'S Exam Prep YouTube channel. And if you wish, you can join me on my personal Telegram channel on BYJU'S Exam Prep, that is Electrical by Ashutosh Saxena. You will get as much assistance as possible from my side. Thank you so much. Take care of yourself, and let us meet in the next session. Shanu Kumar, you can connect to me on my Telegram channel. I will tell you, okay? I will tell you. We'll connect, no problem. Tomorrow also I have a session. We'll discuss some of the problems on fault analysis in power system. That session was missed because of some technical issue. So tomorrow 8 PM in the evening we are having the problems on fault analysis. It is a do not miss session. I am going to discuss very qualitative, very interesting problems for fault analysis. Thank you so much. Take care of yourself, and let us meet tomorrow 8 PM only on BYJU'S Exam Prep. Thank you so much, friends. Thank you. And this candidate Shanu, you please connect to me on the Telegram, okay? I will help you out. I will give you detailed understanding, okay? Thank you, Prince. Thank you, everybody. Thank you, Taran. Thank you. Take care.